Write the standard equation of each circle. Part A. Notice that the radius is 4 and the center is negative 5, 4. The standard equation of a circle is given by the quantity x minus h squared plus the quantity y minus k squared equals r squared. Because the radius is 4, r equals 4. Because the center is negative 5, 4, h equals negative 5 and k equals 4. Substituting these values into the equation gives the quantity x minus negative 5 squared plus the quantity y minus 4 squared equals 4 squared, which simplifies to the quantity x plus 5 squared plus the quantity y minus 4 squared equals 16. So the standard equation of the circle is the quantity x plus 5 squared plus the quantity y minus 4 squared equals 16. Part B. A circle with center at the origin and radius 3 and 5/10. The radius is 3 and 5/10 and the center is 0, 0. The standard equation of a circle is the quantity x minus h squared plus the quantity y minus k squared equals r squared. Because the radius is 3 and 5/10, r equals 3 and 5/10. Because the center is 0, 0, h equals 0 and k equals 0. Substituting these values into the equation gives the quantity x minus 0 squared plus the quantity y minus 0 squared equals 3 and 5/10 squared, which simplifies to x squared plus y squared equals 12 and 25/100. So the standard equation of the circle is x squared plus y squared equals 12 and 25/100. The point 4, 1 is on a circle with center 1, 4. Write the standard equation of the circle. To write the standard equation, you need to know the values of h, k, and r. To find r, find the distance between the center and the point 4, 1. The distance r from the center to the point 4, 1 is given by r equals the square root of the quantity 4 minus 1 squared plus the quantity 1 minus 4 squared, which simplifies to r equals the square root of the quantity 3 squared plus the quantity negative 3 squared, or r equals the square root of 18. Next, substitute the values for the center and the radius into the standard equation of a circle. The standard equation of a circle is the quantity x minus h squared plus the quantity y minus k squared equals r squared. Substitute 1 for h, 4 for k, and the square root of 18 for r to get the quantity x minus 1 squared plus the quantity y minus 4 squared equals the square root of 18 squared, which simplifies to the quantity x minus 1 squared plus the quantity y minus 4 squared equals 18. So the standard equation of the circle is the quantity x minus 1 squared plus the quantity y minus 4 squared equals 18. The equation of a circle is x squared plus y squared minus 2x plus 6y minus 6 equals 0. Find the center and the radius of the circle. Then graph the circle. You can write the equation in standard form by completing the square on the x terms and the y terms. First write the equation. X squared plus y squared minus 2x plus 6y minus 6 equals 0. Then add 6 to each side to get x squared plus y squared minus 2x plus 6y equals 6. Next, group the x terms and the y terms on the left side to get x squared minus 2x plus y squared plus 6y equals 6. Next, complete the square for the expression x squared minus 2x to get x squared minus 2x plus 1. Then complete the square for the expression y squared plus 6y to get y squared plus 6y plus 9. So x squared minus 2x plus 1 plus y squared plus 6y plus 9 equals 6 plus 1 plus 9. Next, factor the expression x squared minus 2x plus 1 on the left side of the equation to get the quantity x minus 1 squared, and factor the expression y squared plus 6y plus 9 to get the quantity y plus 3 squared. Then simplify the right side of the equation to get 16. So the quantity x minus 1 squared plus the quantity y plus 3 squared equals 16. Next, rewrite y plus 3 as y minus negative 3. So the center is 1, negative 3, and the radius is 4. Use a compass to graph the circle. Prove or disprove that the point 3 the square root of 7 lies on the circle centered at the origin and containing the point 1, 4. First, find the radius of a circle centered at the origin and containing the point 1, 4. The radius r is given by the square root of the quantity x minus h squared plus the quantity y minus k squared. Substituting 1 for x, 0 for h, 4 for y, and 0 for k, gives r equals the square root of the quantity 1 minus 0 squared plus the quantity 4 minus 0 squared, which simplifies to r equals the square root of 17, which is approximately 4 12/100ths. So a point lies on the circle if and only if the distance from that point to the origin is the square root of 17. Find the distance from 3 the square root of 7 to 0, 0. Using the distance formula, the distance d from 3 the square root of 7 to 0, 0 is given by d equals the square root of the quantity 3 minus 0 squared plus the quantity the square root of 7 minus 0 squared, which simplifies to d equals the square root of the quantity 9 plus 7, or d equals the square root of 16. Because the square root of 16 equals 4, d equals 4. Because the radius is the square root of 17 and the distance from 3 the square root of 7 to 0, 0 is 4, the point 3 the square root of 7 does not lie on the circle centered at the origin and containing the point 1, 4. The epicenter of an earthquake is 10 miles away from -1, -3, 2 miles away from 5,3, and 5 miles away from 2,9. Find the coordinates of the epicenter. The set of all points equidistant from a given point is a circle, so the epicenter is located on each of the following circles. Circle A with center -1, -3, and radius 10. Circle B with center 5,3 and radius 2, and Circle C with center 2,9 and radius 5. To find the epicenter, graph the circles on a coordinate plane, where each unit corresponds to 1 mile. Then find the point of intersection of the three circles. The three circles intersect at 5, 5, so the epicenter is 5, 5.